Hello students, today I am going to demonstrate an experiment of refraction through glassslab. Aim of the experiment is to verify Snell's law of refraction and determine the refractive index of glassslab. Apparatus required for the experiment are a drawing board, an A4 size white paper, a rectangular glass slab, a scale, a protractor, a pencil and few pins. Fix a white paper on the board using pins. Now place a rectangular glass slab on the paper and draw its boundary. Remove the glass slab and mark the boundary as P, Q, R, S. Mark a point O approximately on the middle of the surface PQ. Draw a normal at point O. Keep the protractor such that its baseline coincides with the line PQ and mark a point for the normal. MON is the normal. Now mark a point for an angle of incidence, say 40 degree, from the normal using protractor. For that, keep the protractor such that the baseline of it coincides with the normal and mark a point at 40 degree. Label this point as A. Join the point A and O. AO is known as the incident ray for angle of incidence 40 degree. Carefully put the glass slab back in its position. Fix two pins on the line AO. Look from the other side RS of the slab by keeping any one eye closed. Align your eyes in such a way that images of two pins appear to be in a straight line as seen through the slab. Now try to fix two more pins in such a way that all four pins appear in a straight line. All the four pins are now in a straight line as seen through the slab. Remove the pins one by one and mark the position with small circle. Now join these points and extend the line up to the boundary line RS. Label the point of intersection as B and this point as C. BC is known as the emergent ray. Draw a normal on RS at point B. Measure the angle of emergence. It is 39 degree. Ideally it should be 40 degree as the angle of emergence is equal to the angle of incidence for the glass slab. But variation of plus or minus 2 degree is fine. So if you get the angle of emergence between 38 to 42 degree, that is alright. If it is less than 38 or more than 42 degree, you need to redo the experiment. Now join the points O and B. OB is a refracted ray. Measure the angle of refraction, which is approximately 26 degree in this case. Now if you extend the incident ray AO, you will get a straight line parallel to the emergent ray. The perpendicular distance between the extended incident ray and the emergent ray is called lateral displacement. Lateral displacement is 1.3 cm. Now put the values of I and R in the observation table. Find the values of sin I, sin R and calculate the refractive index. Refractive index is 1.47, which is almost equal to the ideal value 1.5. Repeat the procedure for two more angle of incidences, that is for 50 degree and 60 degree. Now plot the graph of sin I against sin R. Sin I will be on y-axis and sin R will be on x-axis. Choose the appropriate scale and plot the points on the graph. Join the points. It is a straight line passing through the origin. The following inferences can be made based on the observations. Number 1. Graph of sin I against sin R is a straight line. Number 2. The ratio of sin I to sin R is a constant. Hence, Snell's law is verified. The refractive index of the glass slab is 1.48. In this demonstration, I have used a thin glass slab. Instead of thin, if a thick glass slab is taken, then the refractive index comes out nearly 1.6. In some cases, the refractive index is found around 1.42. So depending upon the material of the glass slab, refractive index may vary between 1.4 to 1.6.